Hey, hi, Radha this side. Welcome to my YouTube channel. So today we will discuss all the four problems asked in today's LeetCode Weekly Contest 466. So let's start with the first problem. It says you are given an integer array nums of length n, and in one operation you can choose any subarray and replace each element of the subarray with the bitwise AND value of all the elements, right? And we have to return the minimum number of operations required to make all elements of nums equal. And we know that a subarray is a contiguous non-empty sequence of element within the array. So if you notice, we can choose any subarray, right? Any subarray, when we can replace each element of the subarray with a bitwise AND value. So if we can choose any subarray, we can choose a subarray that consists of all the numbers, right? So we can choose numbers from index 0 to n minus 1. So this will be your subarray, and we can replace all the numbers with the bitwise AND value, right? It means that the maximum number of operation that would be required is 1, and just pick, and that would be the case when you pick whole array as a subarray, right? So it means that the maximum number of operation is 1, and what will the minimum number of operation? So minimum number of operation is 0, but that will only be achieved if, like, if the given array consists of all the numbers equal. So for there would be just two conditions. One, first check if all the numbers are equal in the given original array, the number of operation required is 0. Otherwise, the maximum number of required operation is 1. So, and that would be the case when you choose whole array as a subarray, and you can replace all the numbers with the bitwise AND value, right? This is the code of first problem. So it takes the nums array. So we just need to check if all the elements in the given array are equal or not, right? So this is one of the easiest way to do it. So either you can do a traversal from all the elements in the given array, and you can check if they are equal or not. But what I have done, I just sorted the given array, and I just checked if my first element is equal to the last element or not. If both are equal, means that the whole array consists of equal numbers. So in that situation, return 0, otherwise return 1, right? So yeah, this is all about the code of first problem. Let's see the second problem asked today. In the second problem, you are given a string s, and that consists of lowercase English letters. You can perform the following operation any number of times. So the operation is, you have to choose any character C in this string, and you can replace every occurrence of C with the next lowercase letters in the English alphabet. For example, you choose P, then the next alphabet of P is Q. So you have to replace every occurrence of P with the Q, right? And ultimately you have to return the minimum number of operations required to transform S into a string that consists of only character A, right? So, and you have to configure the alphabet in a circular order, that is from A to Z. So means that, let's say you want to replace Z. So for Z, the next character is A, like in a circular order. So you have to replace G with A, right? So yeah, this is also a pretty easy problem. Let's see how we can approach it. In the second problem, we have to find out the minimum number of operations required to transform each of the character into A, right? So let's take this string as an example. So we have to convert all of these characters B, C, D, E, G to A, right? It means that so the next character of G to A. So, and one more thing, we cannot directly convert each character to A. We have to do a sequence of operations. So we have to convert. So let's take B. We have to convert B to C first, then convert all the occurrence of C to D, then E, then F, and so on, right? So the last character would be G. After G, it would be A, right? So the maximum number of operation for any character possible is B, because for B we have to find out this sequence: convert B to C, C to D, D to E to F, then up till G, and then A, right? So this is how you convert B to A. And if you notice, when you try to do one operation, you can choose all the occurrence of that character, right? Every occurrence of that character, right? So given that, I hope it is clear that the most optimal way to convert these characters to A would be start from B. So convert all the occurrence of B to C, then all the occurrence of C to D, and then to E, and so on, up till you convert all the characters to A, right? That is because, let's say you started from D, right? You converted all the way from D to A, right? D to E to E. But let's say there is a C left here, then you again come back, and now you have to convert all the C to A, right? So again you have to convert C to D, then D to E, C. So let's say you started from D to converting from D to A, right? So you have done all the operations that, like, so to convert all the D to E, then E to F. But let's say C is left here, like you have not started from C. Then again you have to come back and you have to convert C to D, then D to E, right? So see, this is a repetitive part. Like, so you are essentially, what you are doing, you are doing a repetition. You are, again you started converting D to E. So it is always be optimal to start from the minimum character. So, and that is possible, which is B. So B is the minimum character possible, that has to be converted to A. So start from B, then you start like converting that character to the next alphabetical letters, and until you reach A. So this is the idea. The idea is to start from character B, and you keep on replacing each character to its next lowercase letters until you reach A, right? This is all about the explanation part. Let's see how you can write code for it. This is the code of second problem. So we are given a string S, and this is my frequency array that essentially stores the frequency of each characters. So this is how we do it. We keep on scanning each of the character in the given string S, auto C in S, and we just increment the frequency of that character. So this is my answer. Now what I'm doing, if you notice in the explanation part, the most optimal way to start from character B, that is convert B to C, C to D, D to E, and up till you convert all the characters to G, then G to A, right? So so here actually this index 0 signifies for character A, index 1 for character B, index 2 for character C, and so on, right? So I'm starting from index 1, that signifies character B. Now I'm just checking if the frequency is positive, like if we have to convert any of the characters to the next immediate character or not, like, so just check if the frequency is positive. If that is positive, means there are few characters, like few occurrence of that characters, right? So increment an answer. Now what I'm doing here, I'm just converting current character I to the immediate to its immediate next character, which is I plus 1. So I just incremented the frequency of I plus 1, right? So frequency of I plus 1 plus equals to frequency of I. So here I'm taking modulo because see, this is in a circular order, like you can convert character Z to A, right? So this is only to handle that case when you want to convert character G to A. So in terms of index, you want to convert character 25 to 0, right? So 25 plus 1, 26, 26 modulo 26 is 0, right? So this is how your frequency of 0 is incremented, right? So once you converted your current character to the immediate next character, so just make the frequency of current character to 0, because you have converted every occurrence of that character to its immediate next character, right? And at the end return your answer. So yeah, this is the code of second problem. Let's look at the third problem. In the third problem, you are given an integer array nums that consists of distinct elements. So a subarray from L to R is called ball if its length is at least 3 and the minimum of 2 of its end elements, that is the first and the last elements, the minimum of them is greater than the maximum of all the elements in between. So that means the minimum of nums of L comma nums of R is greater than maximum from L plus 1 to R minus 1, right? And we have to find out how many number of ball subarray is possible in the given nums array, right? So, and we know that a subarray is a contiguous sequence of element, right? So this problem is essentially a variant of a very famous famous problem that is asked in multiple interviews called next greater element or next smaller element or previous greater element or previous smaller element. So like the most so the problem which is most close to this problem is this one, previous greater element. So this, all these, previous is greater, previous is smaller, next greater, next is smaller, all these are the same problem, like the implementation is more or less same. And the the algorithm that is used to solve this problem is to use stack and amortize complexity. So I would highly recommend to solve this problem first, to find out the previous greater element or the next smaller element or the next greater element. Anyway is fine. I mean, all the four problems are more or less same. They uses stack to kind of optimize the complexity. So yeah, please solve this problem first. It would be easy for you to solve this problem, right? So yeah, let's see how we can approach it. To solve the third problem of today's contest, we will first look at how to find previous greater elements of each numbers, right? So let's say you are given integer array and we have to find out the previous greater element, right? So let's take example. So for this is my given array 63215213556. Let's say you want to find the previous greater element of 5, right? So previous greater element of 5 is 6, right? I would like to ask you one thing. Does these numbers matter? I would say no. That is because, see, the objective is to find out the previous greater element, right? And to find out the previous greater element, all that matters is the numbers which is greater than me on the left side. For example, for 5, the number which is greater than me on the left side is only 6. So this 3, 2, 1 doesn't matter at all. So what we do, we kind of create a stack, and in this stack, so see, if these numbers doesn't matter, it means that you only want to keep the previous greater numbers, right? Means 6, and for 5 it is 5. So see, all these numbers are in decreasing order. That's what essentially this stack stores. This stack essentially stored the numbers in the decreasing order, because if the number which is smaller than current number in the previous part, it like so we don't want to entertain those numbers, we will just ignore those numbers, right? Because so let's say let's see, for 5 we have, like, the stack would look like 6 and 5, right? The previous greater numbers 6, now current is 5. Let's say now you want to find out the previous greater for 2. For 2, we will just check if my previous like the top of the stack is greater than me or smaller than me. If it is greater than me, it means that this is my previous greater number. So the answer for 2 is 5. Now we will insert 2 here. Now similarly for 1, we will check the top of the stack. The top of the stack is greater than me. So here what I am doing here, so I am keep on popping all the numbers which are smaller than me. So ultimately what you will left with the greater number. So for 1, the top of the stack is 2, means that the previous greater element for 1 is 2 itself. So you take it and now you insert 1 here. Now you come to 3, right? As I explained earlier, for 3, what is my previous greater number? 5, right? It means that 2 and 1 doesn't matter. So what we will do, we will keep on scanning from the stack. We will check if the top of my stack is smaller. If that is smaller than me, just pop it out. So 1 is smaller than me, so pop it out. 2 is smaller than it, pop it out. Now 5 is not smaller than it. It means that this is my next, not next. So this is my previous greater number. So now once you pop 2 and 1, your stack would look like 6, 5, and then you insert 3 here, right? Now you come to 5 here. Now you have to find out the previous greater element of 5. So for 5, see, the previous greater element is 6. It means that all these numbers doesn't matter to me. So I'll just keep on scanning from the top of the stack. 3 is smaller than or equal, 5 is 6. So this is my answer. So now your stack would look like 6, and then you push 5 here. That's what we are doing here. Push 5. And then for 6, see, for 6, is there any previous greater number? No. So you keep on scanning from the top. 5 is smaller, 6 is smaller than equal, cut. So there is, for once you do this while, for once the while loop execute, your stack would become empty, right? There is no element. So if there is no element, means that your, so if your stack is empty, means that there is no so there is no previous greater number than the current number, and that is true here, right? So if so originally your answer is -1. So if you get, so if your stack is non-empty, you get the number, otherwise your result is -1, right? So this is how we calculate the previous greater element of each number. So if you notice here, for any of the element, it would be pushed or pop in the given stack at most 2 number of times, right? At most 2 number of times. That is why the amortized complexity for this algorithm become order of n. So this is called amortized time complexity. You can learn it from the online tutorial. So yeah, this is all about the explanation of how to find the previous greater element. Let's see how we can use this knowledge to solve the third problem asked in today's contest. This is the code of third problem. So I'll explain what I have done here. So we know that for a subarray to be a ball, the minimum of end numbers and nums of L, nums of R must be greater than the maximum in between, right? So there are 2 cases that needs to be considered. Case 1, let's talk about case 1. Let's say this is my current number x that is present at index R, right? Now at index L there are 2 possibilities. Either that number is greater than x, or case 2, if that number is smaller than or equals to x. And this is my current number x, this is my index R, and this is my index L, right? So there are 2 cases only. If that number is greater than x, or if that number is smaller than x, is smaller than or equals to x. Let's consider the first test case. If that number is greater than x, and we know that all the number that is present in between, right? All the number that is present in between. So in this case, if this is x, this is greater than x, it means that all this number present in between must be less than x. That is because minimum of these 2 is x, right? Minimum of these 2 is x, and x has to be greater than the maximum in between. So all this number has to be smaller than x. Now for the second test case, if this is greater than or equals to x and this is x, the minimum of these 2 is this number, right? In that situation, let's say this number is y, right? All this number has to be less than y, right? Has to be less than y. So in the first case, can I say this number is the previous greater number? Previous greater number? Yes, because that essentially what previous greater number is. You have to find out the previous greater number, the first previous greater number, and all this number must be smaller than x, and that essentially what it called the previous greater number. So in that situation, and one more thing, can I say, so let's say this is 5, let's consider this is my 5, this is 1, 2, 6, and let's say 1, and let's say 8, right? So for 5 the previous greater number is 6, right? So this is a ball. If you see, this is a ball. The minimum of these 2 is 5, which is greater than this. This is a ball. But is this a ball? No, because the minimum of these 8 and 5 is 5, which is greater than the maximum. It means that if this number is greater than x, if the previous number is greater than x, right? If you want to create a ball such that the number present at index L is greater than number present at index R, it has to be only your previous greater number. That's it. No other possibilities. As we discussed here, right? As we have seen here, for 6 it is good because this is the first previous greater number. but for it is not possible, because we know that 6 is greater than 5. So we have already encountered a number which is greater than 5. So if you are trying to create a ball with the previous greater number, which is kind of not the first previous greater number, it won't be possible. So for case 1, only one possibility is there, that this number has to be your previous greater number. That's it. Now come to second case. If your previous number is smaller than or equals to x, in that situation, you keep on iterating from the stack, and you check that. I'll explain in the code part. So see, this is my size, this is my answer, this is my stack. Now I'm going through each of the number from the array. This is my current number x, and this is the in between max. So this is a variable that essentially store the in between max, right? Now what I'm doing, I'm just doing while not st.empty, and your nums of st.top is greater than or equals to x. So this is for case 2. So this is for case 2, and this is for case 1. So let's look at the simplest case first, case 1. So if your if your stack is not empty, and your current index minus st.top is greater than or equals to 2, so this will take care of. So since we know that your number has to be greater than or equal, your total Subarray size will be greater than or equal to 3, right? For the difference between L and R must be greater than or equals to 2, right? So let's say 1, 2 and 3, 1, 2 and 3. So 3 minus 1 is 2. So it has to be at least 2. That's essentially what I have checked here. If my stack is not empty and the difference is greater than or equals to 2, means that there are at least 3 numbers. Increment the answer, right? So this is the case 1. Now for case 2, I'm iterating through the stack, and I'm just checking if my top of the stack is less than or equals to x, right? This is less than or equals to x, L. If that is true, and now we are trying to find the mean int. This is mean. We are trying to find the mean int. So the mean int is the minimum among. So the mean int means the minimum among the int numbers. So int numbers are nums of L and nums of R. So these two are the int numbers, and that has to be greater than the max in between, right? So the mean int is the minimum among st.top and x. So you might be thinking that why I have considered all these numbers only that is present in this stack. Why not those numbers that is not present in this stack, right? The reason is we know that in this stack the numbers would be in a decreasing order, right? So 8, 7, 6 and 5. Let's say the numbers are in decreasing order, right? And you are trying to form a subarray that whose, let's say, the current number is 7, right? For the number 7, we know that in the stack, though we have 8, 7, 6 and 5, but this is not the actual number present in the original array. The original array may look like 8, let's say the numbers are 1, 2, 3 and then 7. We know that we don't care about these numbers. These numbers will be ignored. In the stack, we will only push 8 and 7, right? We don't consider about 1, 2 and 3. We will just ignore these numbers. The reason is we have to find out the maximum among in between, right? So to find out the maximum in between, does these numbers matter? No, because we know that my current number is anyway greater than these numbers 1, 2 and 3. Why not consider only these numbers? So that is the reason why we are trying to keep the numbers at this place, only those numbers that is present in the stack, but not in the original array. Original array may look like 8, 1, 2, 3 and 7, but we are ignoring these numbers. We are only keeping 7, 8, the numbers which are present in the stack, because we essentially have to find the maximum, right? The maximum in between. And so to find out the maximum in between, only these numbers matter, 8, 7 that is present in the stack, not the number that is ignored, right? So yeah, that was that point. Now if that is the case, now we have found the mean int. Now I'm just checking if the minimum like if the length of the subarray is greater than or equals to 2 and this mean int is greater than in between maximum. So in between maximum, the mean int is greater than in between maximum. If that is the case, just update your answer plus plus. Now just update your in between max. So in between max would be maximum of current comma nums of st dot top, because as I mentioned, this is my current number x. So I will be I will be putting few of the numbers from the stack as a candidate of this place, right? So once you so let's say this is top of the stacks. Once you pop it out, you keep this number as the top of the stacks, but at the time when you will configure second number at the top of the stacks, this number will configure in between. Now this number become in between, right, in between. That is why I updated my in between at like using the top of the stack, right? And st dot top we already configured case 2, so yeah, add then return your answer. So here is the code. This commented code is how to find the previous greater than element, right? So both the code has been explained in the explanation part, so please check it out, right? And yeah, this is the code of third problem asked in today's contest. So yeah, this is all about the third problem. Now let's look at the fourth problem. This is the fourth problem asked in today's content. So it says you are given a non-negative integer n. Now a non-negative integer is called a binary palindrome if its binary representation reads same from backward and inward, right? So we already know the definition of palindrome. Now we have to return the integer k such that k is from 0 to n and the binary representation of k is a palindrome, right? So essentially in this problem we have to find out all the numbers that is from 0 to n, and first that its binary representation is a palindrome. For example, 9, the binary representation is 100, and this is a palindrome, right? So yeah, this is the fourth problem. Now let's see how we can approach this problem. This fourth problem is a bit of ad hoc problem, so I would like to explain it through the code itself. I believe it would be easy for you to understand, right? So here I created a function called count for length, which essentially gives you the number of palindromes possible for a given length L, right? So let's say this is a palindrome. I want to form a palindrome of length L, right? And this palindrome consists of zeros and ones, right? 0 and 1s. So let's divide it in the half. This is my L by 2 and this is my L by 2, right? We know that for a palindrome of length L, your leftmost bit has to be 1, right? Because if the leftmost bit is 0, then the length of the palindrome would be L minus 1, right? Because we know that the leading zeros are not configured in the palindrome. So it means that this position is fixed, which is 1 should be placed here, right? So what is left? Left is L by 2 minus 1, right? So we know that for these many places we can either put 0 or 1, right? So there is no restriction on these numbers. So now how many possibilities, so how many palindromes are there? 2 raised to the power L by 2 minus 1. That's what exactly I have done here. So this is for the case when your L is even. So if L is even, k is L by 2 and your number of palindromes are 2 raised to the power L by 2 minus 1, right? Because your first place is fixed, 1 should be placed here. Now similarly for the odd case, if L is odd, your k is L minus 1 divided by 2 and your total number of palindromes possible is 2 raised to the power k, right? This is for odd case, this is for even case. So this is the first function which I have created. Now let's look at the explanation of so how to approach for a given length n, right? We know that for n is equal to 0, your answer is going to be 1 because 0 is the only palindrome possible. For n is equal to 1, 2 possibilities, zeros and ones. Now what I have done here, I have converted this given integer n into the bit form, right? So for 9 it is 001001. That's what I have done here. I have find the bit array, and so this is my bit array. So once you get the all the bit set, just reverse it. So this is so after this you get the bit array. For 9, for example, it would be 1001. Now what I have done, now the step 2 is to find out all the palindromes that is having length less than m. Right? We know that for a given for n, the length of the binary representation is m, right? So for m is equal to 0, for length is equal to 0, 1, 2, 3 up till m minus 1, all these are the valid palindromes, right? All these numbers would be always be less than or equals to n for sure, because for n the binary representation has length of bit set is bits are m. So for those length whose binary representation have the total number of bits less than m minus 1, that will always be less than or equals to m, right? That is what exactly I have done here. I have added this to my answer for L is equal to 1 to m minus 1. Right? Now for so in the third step we have to find out the total number of palindromes with length m, and that's all. That's, I mean, our problem is solved. First we calculated for length 1 to m minus 1. Now for m, what I have done here, so this is my half, the half of the value, right? So the total length is m, so the half would be m plus 1 divided by 2, right? So considering both even and odd case, right? So here if you see here, now what I have done, I have found the numeric value of first half bit present in the binary representation of n, right? So for the first half here I have calculated the numeric value of the first half. Now I have calculated the start value. So start essentially is the minimum valid prefix of length half. So let's say you want to find out the minimum number that has the so the number of bits in a binary representation at half, that is the number would be, the first bit would be 0, rest would be 0, right? So the total set, so the total number of bits are half, right? So this number is 1 left shift half minus 1, or in the other terms 2 to the power half minus 1, right? So this is what I have calculated. This is the start value, so the minimum valid prefix of length half. Now what I have done, I have count the palindromes that is formed by the smaller prefixes, right? So this is my first value. So the first value is the half of the, so let's say this is the binary representation of n, right? So you take the half of that, you take the first value, right? The first half value. So if this value is greater than half, the minimum possible number, right? If the first value, the value is greater than start, what I have done, I have incremented the answer because there is many number of palindromes that can be formed by the smaller prefixes, right? So this is my answer. Now the last case would be to check. So this is my half, right? So sorry, let's remove that. So this is the binary representation of n. Now what I have done, I have taken the half value, I have taken the mirror image of it. So let's say this is 1001, right? I have taken the mirror image of it, so it would be 101001. And now I want to check if this is less than or equals to n or not. That's what I have done here. The last case would be to just check if if you mirror image of it, that number is less than or equals to n. So this is how I have calculated it, and then I have checked if this palindrome is less than or equals to n. If that is true, your answer should be incremented by 1. So yeah, at the end return your answer. Yeah. So this is the code of fourth problem. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.